In this issue of Spacecraft Guide, I am going to continue to teach you how to fly the space shuttle, and I am also going to show you how to use this virtual reality tour of the shuttle, where you can actually zoom into parts of it, like this over here on the command module, this panel, and also be able to click on the components like we've been doing with the primary flight display. And that's at the end of the video. I'll show you how you can be able to do that by joining my Patreon page. But first, before we do that, we're going to now go from the primary flight instruments to the actual switches that control the primary flight instruments. And this week we are going to work on the HSI mode selector entry switch. And when you click on it, it takes you to the HSI select mode entry switch, which is this switch right here. Now, this is a very important switch. It enables the HSI auto switching of landing mode, the entry TAEM, or approach. These HSI area navigation software modes are slightly different from the guidance phases, virtually identical with identical names, entry, TAEM, and approach and landing. The landing position enables the HSI mode auto switching from entry to TAEM to approach, or the TAEM and approach modes can be entered directly, respectively taking the HSI select mode switch to TAEM and approach. Now, one of the things we need to explain here is entry is actually, this phase is when you're entering the atmosphere. So you enter the atmosphere, and when you come from outer space, you go into the atmosphere, and that'll take you to TAEM, which is Terminal Area Energy Management. So what you're doing is, okay, you've broken into the atmosphere. Now you're going to go from a few 100,000 feet down to where you can do the approach. And this approach is going to be either in the TACAN or the microwave landing system. And that is, you can see all of that is going to be, we're going to go here back to this part of the shuttle. And this is the HSI. So the error needles and the roll needles and roll error needles and the pitch arrow needles and the yaw arrow needles, this is all going to be selected for either the entry, which is coming into the atmosphere, or the TAEM, the Terminal Area Energy Management, or the really important part, the TACAN and microwave landing system. So that switch that we're talking about is going to affect these needles. And if you are a Patreon subscriber, even a free Patreon subscriber, we're going to show you, I'm going to go into the schematics, bring up a diagram and show you exactly where the entry, the TAEM or approach is going, how that is going to affect the spacecraft by selecting points on this switch. Now, on the other thing I wanted to say is the switch, if we have it in the entry mode, that's in an auto mode, so it automatically goes from entry to the Terminal Area Energy Management section to the approach section. It's going to do it automatically, but let's just say, for instance, that you've gone through the atmosphere and you need guidance for slowing down. You need terminal area energy management. You have to manage the energy that you're bleeding off so you can come into land, but it hasn't switched that mode. What you're going to do is you're going to move this switch to TAEM, and that's going to force the needles that I showed you before, the row, yaw, and pitch error needles to the team so you can actually bleed off that energy and get ready for the approach. Or let's just say you've bled off the energy and you're coming up to the approach and you need that microwave landing system. You're going to move this switch into the approach mode, and that's what that switch does. It's very, very important for flying the space shuttle. So let's go into the schematics for our paying and free. And if it's free, why aren't you being part of it? I'm going to show you down below. It's part of the Spacecraft Interactive Virtual Reality Museum, where you're going to be able to go in to the schematics here, and you can look at it all for free. All you have to do is sign up with an email, and then I'll give you weekly updates. You'll get information that you don't see here, and you'll get this information I'm talking about before anybody else. So what are you waiting for? It's free. So if you are a Patreon subscriber of mine and you click on schematics, it takes you to this HSI function matrix, and you can see the HSI mode, which is going to be from that switch that we're talking about. You have entry, TAEM, and approach. So here in entry, we have bearing and range, and it's a bearing to waypoint 1 for the normal entry procedure at primary landing runway. And then secondary is waypoint 1 normal entry procedure for the secondary landing. And then the range is spherical surface range, or the distance from the waypoint 2 on the primary runway via waypoint 1 for the normal entry procedure, and a spherical surface range to waypoint 2 on secondary runway via the waypoint 1. All right, so all that's for the entry. That's what it's going to be doing. Basically, it's going to get you through into the through entry to the atmosphere and set you up for the landing at the primary runway or the secondary runway. Now the team, that is the terminal area energy management. We're going to start bleeding off our speed because we're going to be going very fast, 25,000 miles a second, and we're going to slow that down to 290 miles a second. So here the bearing again to waypoint 1 on selected HAC for primary runway, and bearing center to the selected HAC for the primary runway. And then here the horizontal distance. So the range is going to be distance to waypoint 2, as you can see, for the selected entry point, and the horizontal distance selected distance to center of selected HAC for the primary runway. And then here is the bearing to waypoint 2 at the primary runway, bearing to waypoint 2 at the primary runway in secondary, and then in primary for your range, it's the horizontal distance to waypoint 2 on the primary runway, and the secondary is the same. Now, what is very important here is you're not going to get a flag when you're in the entry. It's the GPS is stowed, but you are going to get a magnetic heading on the compass card. So you're going to the 0 here. Of course, when they say a valid software 0, that's when you're on course for this entry. That is where you're going to get this compass card here. And now here in TAEM, it's deviation from extended runway center line. So you're off the runway center line. The full scale is 10 degrees. And this is from altitude. The full scale up and down is 5,000 feet, and you're on magnetic heading of the body of the x-axis. And again, everything is on magnetic heading because the runways are based on magnetic heading. Now for the approach, now that can be TACAN or nav, that's going to be a deviation from the extended sun array, and instead of 10 degrees, it's going to be 2.5. And then for the glide slope, it's going to be plus or minus 1,000 feet. So 1,000 feet is full scale up or down, but it's not computed below 1,500 feet if the flag deploys. So if you get a flag, you're not really going to know if you're on the glide slope. And again, magnetic heading for the bases. So what this is all based on is up here. Now you can see this is the team, the or TAEM, the Terminal Area Energy Management Interface. So that's when it comes up to there. And now after that, you're going to start into the approach and landing interfaces. And we can see the TAEM is the height, you're 83,000 feet, the velocity is 25,000 feet per second. Your range is about 60 miles, 68 statute miles. Your heading is 10 degrees. So here you're coming in, and now you're getting ready for your approach and landing interfaces. And these circles here, this is waypoint 1, and then we have our waypoint 2. Waypoint 1 is entry, getting set up for the approach. Think of this as if you're a pilot, initial approach fix, and you're coming into waypoint 2, and that happens to be the runway. So this is WP1 as we saw in the chart, and this is WP2. Now, if you come down here, this is a sideways reference. I like this reference. It's really good. So you see yourself, you're coming down. This is actually the cone right here that is going to take you where you're going to circle around and lose altitude till you get to the altitude you need for the normal entry point. So here is your waypoint 1. If you did everything correctly, you only will have to do one turn here for the runway. And then here is your normal entry point, the NEP. And then here is the waypoint 2, which is the end of the runway. And then here is this, they call it the steep glide slope intercept. And it is very, very steep if you look on it. And this is the final approach shallow glide slope. So you see you're coming in really steep. And this round here is when you're slowing down, getting the gear out, and touching down. So that is, I know it's a lot, but that switch is controlling all of this from coming to the entry, to the TAEM interface entry, to the approach to land. And so this makes it a very important switch. And you're going from 100 and some miles above the Earth down to 83,000 feet at a velocity of 22,500 feet per second. And then you're going to 10,000 feet. Hopefully you'll hit this point at 10,000 feet and at 290 feet per second, which is by almost a factor of 10, you've slowed down and you're coming into land. Now that is everything for our free subscribers. If you are a paying subscriber, and it's $5 a month right now, and at the end of this video, I'm also going to show you, well, you can actually join up for $5 a month since you're a free member. You can just and I think we might have some deals for you. If you look a little closer, I think we can get you 20% off if you join with us this month. So if you look at that, it's I believe still under uh, the 56th anniversary for Apollo. We might have a couple more for you, but if you are a paying subscriber, we are going to go into deeper into it. So come join us, and now we're going to go in for our paying subscribers. We are going into the Tactical Air Navigation, or TACAN unit. What basically this is, for our pilots, TACAN, it's like a VHF omnidirectional tactical air navigation, or VORTAC ground station. It is an electronic navigation beacon, and what it does is it's a box, and the box puts out radials that the pilot can fly to. So it actually will tell you what kind of a radial you're flying on. So this, like, if this straight up is 360, this is 270, this may be like 310 here, 310 degrees. So it will be able to tell you exactly how to fly to that station. And that is a great thing. And also it'll tell you the distance from that station. And this is what you navigate through when you're in the approach segment, when you're past the terminal area energy management system, where you've slowed down enough. Now you have to navigate to the runway. This is what the TACAN is going to do for you. It is going to give you the distance that you are from the radio beacon, and what radial you are off of from that from the beacon. And from that, you can navigate to the end of, that'll set you up for the instrument that's going to guide you to land safely on the runway. This is to get you within the airport area, in the runway area. And then the next thing that we're going to do is look at the microwave landing system. And test, test, test. We scroll down to the microwave landing system, and you actually have, like the TACAN, when you have 3 onboard microwave landing system units that are navigation and landing aids for the pilots to use to get to the end of the runway. So, like the TACAN, it gives you the distance from the end of the runway. It tells you if in the degrees, plus if you are on what they call the localizer, which is, are you lined up with the runway? And it's going to give you the slant range or glide slope that you need to safely come to land on the runway. So as you see, here is a better one. You have DME, or distance measuring equipment, on board. Here is the runway, and this is actually at the end of the runway. So azimuth station, they have an RF, and basically what this is going to tell you is how to get to the end of the runway. It's going to tell you to steer left or right, and either to come, if you're too low on the coming in to the runway, it'll tell you to pitch up or to come down. And the way that that is done is, if we go back to the cockpit and go to the HSI, it's going to be here on the HSI, the attitude ball. So here, this is the glide slope here, up and down. So as we stated before, if you're close, it is 1,000 feet up or down that you are from the glide slope, and then 2.5 degrees either side of the runway. So these pointers are going to move and tell you where to go. So if this green indicator here moves 1 degree here to the right, you steer the airplane one degree to the right to line up with the runway or the course that you need to be on to line up with the runway. And if the same thing with the glide slope, if the green needle goes up 1 degree, you have to pitch the shuttle up 1 degree to get it back on glide slope. But one thing you definitely don't want to do is see that needle go up higher, because then you have to pull the nose up, which slows you down, and you've got a certain speed already with the spacecraft, and there's no engines. You're working on gravity to get to the ground. So it's very crucial that you keep these needles centered, this one and that's where the error needles come into play. So that is all that I have this week for you, with a lot of extra information this week, because that was a very, very important switch. That's the one that gets you onto the ground safely. So I hope you enjoy this. I hope, please tell everybody to come to our site here and join us in creating this great environment that we have, where we can all learn about the space shuttle and how to fly it and how it's flown. And then hopefully we can build on the space shuttle. We'll go through more systems. But I do really appreciate your support. Your monetary funds really do help me. If you can find someone else to help pay for, or to join us in one of the tiers to pay for all this stuff, I would really appreciate it. And once again, I thank you.